Welcome everybody to our panel on how spatial computing is reshaping manufacturing. I don't know if any of you were able to attend Ori's opening remarks today. I thought they were particularly relevant given what we're seeing in manufacturing right now, especially for the United States markets, having to really face a lot of pressure for reshoring rapidly and scaling production while it takes time and energy and materials to build new facilities. The real pressure is on to do more with less. And at the same time, we're seeing a convergence in all of our evolution of XR technologies, where now we have tools that can help make this a reality that we wouldn't have had 2 years, 3 years ago, or even been able to think of them. So I think our team has a lot of really interesting insights to share. And we're at an interesting convergence right now where digital transformation pressures are driving a lot of how we move forward. And in manufacturing, we're having to reinvent the wheel and run with scissors at the same time, right? To keep up with that. But fortunately, we've got the tools to do it today, and we're able to do more than we've ever been able to conceive of in the past. So our panel is delighted to share with you a lot of what we've learned and what we're still learning. And we're going to plan some time at the end for your questions. And please don't hesitate to raise your hand. Please come to the microphones we have on both sides. We have really bright light in our face here, Mike. Wow. So if I don't see your hand, forgive me. If you come off to the side, I'll probably see you. So without further ado, I'd like to introduce our panel. I'm Lynn Welch. I work with Lucid Reality Labs. And our team works on XR solutions that span across virtual reality, augmented reality, and artificial intelligence to really transform how some of our manufacturing clients are able to deliver higher capacity, improve their safety records, and really improve the quality of what's coming off the line. And a lot of our solutions are involved in the product development phase all the way through active line operations. Our sectors are medical technology, pharmaceuticals, and a lot of automotive and industrial manufacturing. And the rest of our amazing panel are involved in some other really fascinating areas of manufacturing. So Alex, I'm going to turn to you first. Introduce yourself, give us a little background, and then Sandhya and Derek.
All right, this thing's on. Cool. I'm Alex Goldberg. I work for Blue Origin. I'm a senior technical product manager in spatial computing. It's my 5th year up on the stage at AWE. It's great to be back. I appreciate Ori and Sandhya and Nate and everybody's hard work to make this event possible. I love coming here. I only get to go to a few conferences each year, and this is one of my favorites. So super stoked to be back. I came from the game industry. I made a lot of different mobile apps for both entertainment and enterprise end users. I first started with spatial computing at REI, the outdoor store, where I was a producer on their mobile app. And I built AR tents and virtual footwear try-ons where you'd point a mobile device at your foot and see a different shoe on you, as well as digital twins of our stores and our distribution centers. Joined Blue Origin around 3.5 years ago, and I kept going with the digital twins, what we call reality capture at Blue. I also lead what we call AR for M, Augmented Reality for Manufacturing. We have XR solutions deployed on the shop floor in Seattle, where our headquarters is at, here in Southern California. I'll be staying down in the area for 3 weeks, supporting teams in Altadena and North Hollywood. We also have our manufacturing complex in Huntsville, where our engines are made, as well as where we assemble what we call final assembly and some manufacturing in Florida, Cape Canaveral. We also have LC-36, the launch complex at Kennedy Space Center. And we also fly New Shepard out of Van Horn, Texas, where we test our engines. At all of those facilities, we have active spatial computing solutions, whether it is augmented reality for manufacturing on the HoloLens 2, which can be leveraged for work instructions, or remote assist, where somebody, subject matter expert, kind of teleports in. as well as an active digital twin initiative that we call reality capture, that we have embedded training material in those twins. So a lot of XR stuff going on at Blue. Happy to be here.
Well, my name is Santhosh, and I'm a senior research scientist at Collins Aerospace Applied Research and Technology, which is an RTX business based in Ireland. I'm from Cork, so this is my first time at AWUSA. Everything is massive in US compared to Europe. So, but at Collins Art, we are mostly focused on to research and development into innovative technologies or tools which can augment and optimize our processes in the future. So my research especially focuses on some of the concepts such as human-centered design, human-machine teaming, human autonomy systems, etc., and how XR or innovative tools such as spatial computing facilitate and enhance these kind of systems or approaches is my area of focus. And as a certified remote pilot, I also bring keen interest into unmanned aviation management. So drones, drone deliveries, how augmented reality can support this, how AI can support this kind of infrastructures, or how we can build this kind of environments where we can have optimized workflows to achieve the system, to achieve the results faster, to make the human more aware of the situation, to make faster decision makings. So these are the three key components where my research is focused on, and happy to be here.
My name is Dreier. I work at the Boeing company. I'm an associate technical fellow there. I started back in 2004, quite a while ago. I started more on the defense side at Boeing, mainly as a software engineer, creating like front-end systems, middleware, and back-end services. And through the years, we've slowly went from like more defense systems to satellite systems. And then I happened to cross paths with Paul Davies, who worked at Boeing. He was doing a lot of AR research back in the day, before the HoloLens and other stuff, where it was very more like Doc Brown from Back to the Future, where we had laptops, Xeon machines, capture, motion captures all over the place. We used to have like stuff where the satellites were being built and these capture systems all around with tracking your tablets and just wires and cables coming out of notebooks and stuff. So it's crazy back in the day. And then we started getting into productizing and spreading what we call the Boeing Augmented Reality Kit throughout Boeing, which is kind of like a universal tool. We had to figure out how to scale the solutions across a multitude of different programs, both on the defense and the commercial side. So we have our solution that it's all about manufacturing, assembly, inspection, quality control. We have stuff on the 777X, 787, or defense side, the V-22 or the F-15. We cross all boundaries, and each program is different, has their own unique challenges. In Boeing, there's like microcosms of how different programs do their things. So we had to learn how to be adaptive and kind of like architect a solution that could scale through for all these different programs, so not having to build one-off solutions. So that's been my main focus for the past few years.
So we'll jump right into our discussion points. Thanks so much for the introduction. I know we had met briefly online to coordinate our panel, and I learned more new things about all three of you in that introduction. So one of the things I mentioned earlier was the pressure on supply chains and the pressure on increasing productivity. And with the renewed interest in domestic production, how is spatial computing helping your organizations be a bit more agile and move faster, whether it's scaling up operations or coordinating across sites? So I'll address that to you first, Alex.
Sure, we can just keep going in that order, stick to that. Okay, with digital twins, people can remote in and they can take measurements where they'd have to contact somebody on site or travel to that location and perform a measurement. I know it's like a simplistic task, but to be able to do that remotely just by going to a browser and kicking off that session and invoking that digital twin is just a huge win. we could also interact and leave notes in those spaces. So like I could notice something that I want to discuss. I could ping somebody in that note, and then they'll get an email. And when they open that email and click on it, they get sent there inside of the digital twin. And now we're having like a asynchronous conversation about this thing. And you can manage that as a task where you can mark it complete or keep it open and manage that and get results and look at those metrics and analyze things. So that's on kind of the reality capture end of my XR program. And on the AR end of things, remote assist again on those headsets, the ability to bring in an SME is just such a huge game changer. It's, that has been our bread and butter of the AR program, the ability to deploy a headset and then have that capability.
Great.
Yeah.
I think that's a game changer in there, as you mentioned. Not having to wait for a subject matter expert to get on site, and even if you can get one on site, that does a huge amount to keep everything moving forward.
And you know, there's one more aspect that I should mention, and that's called one less man. So we have teams that work in very hazardous conditions. And if you can have people remote and observing what that one person sees, as opposed to having those X amount of people deployed to some of those very hazardous conditions, that is a huge win that's also predicated on the remote assist capability.
Thanks, Alex.
Yeah.
How about you, Sandhya?
So I'll give a different perspective on what we are working. Apart from AR workflows or instructions going, remote experts coming in to support this kind of environments, RTX, we are a globally distributed organization. And when we start with design of a product, we use virtual environments. Today, we have teams come into this design through virtual environments, collaborate with each other in real time to make changes in the design or to see if there is something wrong, if there are inefficiencies for safety concerns or anything. So bringing that aspects early in the product design and development does support a lot of faster decision making, and it will improve a lot of speed and performance of the development process. So we have this kind of agile environment, which is also flexible and modular, where we can have multiple people with different roles and skills, actually, be it manufacturers, be it customers, end users who are the frontline users of the product, getting into that space to understand if there are pain points, if any, to have that human factors assessments way before the product is built is supporting a lot for us. So that's actually a glance of human-centered approach also. So
No, I love that. And in some of our work in the healthcare sector and in manufacturing, when they're building and planning for a new production model on floors that get reconfigured often in auto manufacturing, the ability to run that in simulation, understand what's going to work well and what's going to be a blocker is a completely different approach than what they tried before, as opposed to building it all physically and then figuring it out and then having to change the model and missing deadlines. And surprisingly, in healthcare, as they're building new hospitals, they're leveraging digital twins in that way. And they're looking at, 2 years to build a hospital, and where's your patient population going to be in 5 years? And which departments are going to need to surge and expand. And sometimes just running those simulations so you can look at, let's say there's another massive pandemic, let's hope not, but all of a sudden you have to surge your ER department. If you bump your walls out 5 feet on either side, you can have surge capacity. Or if you plan for a larger number of patient rooms in geriatric wings for aging population, you're thinking 5 years ahead, and you can run those simulations. So it's fascinating, that use case. And I think it applies not only in manufacturing, but across the board. And Derek, how about you?
I'll touch on the agile aspect again a little bit more. So Boeing is a massively large company, and often you learn about other programs and projects sometimes through external means, not even internally, as you not even know what the left hand and the right hand are doing. In that aspect, when a lot of AR, like when the HoloLens came out around 2016 or so, there was a lot of different projects and Boeing just experimenting with it. And they were creating a lot of like one-off solutions. spending a lot of time creating a specific customized solution for this particular use case. And our team, we kind of like did the opposite. We were like trying to be disciplined and try to, accumulate or factor out the use cases into a common source code, because most of those programs died off. They just, it becomes too much cost. It's not cost effective to invest so much in one particular use case. You have to think broader and reuse so that the company is actually cost effective to bring AR to the company. So you have to think a little more like, well, how can we adapt this use case and that use case together and make a common software solution and make it affordable for the company and continue development and improve the product too. So that's kind of like how we've been doing, addressing like agile and being flexible and adaptable, because there's enormous use cases, and sometimes you just got to say, we're going to hold off on that. Maybe down the line we'll do that one, but concentrate on the core ones that the majority of programs are using, and have that reusable so that we can deploy it quickly and support a lot of programs. And that's the most cost-effective way.
I have a couple other things I want to mention. When you talked about the floor plans, it makes me think about one of the things that I'm super excited about is the ability to open up a digital twin and have a form field that you could input part from our CAD PLM. Then you could drag and drop the as designed model right into a digital twin and start manipulating that. That is huge, and that's something that we couldn't do just a few years ago. There's a vendor called Preview 3D. They're a Canadian company based in Montreal. They take that sort of thing a step further, where you can lasso objects that are actually in your scan and start manipulating those, create your own pivot points, and start to adjust like
reality. Having a remote expert guide through them does help a lot in understanding and in making the frontline users especially adapt to the systems. And digital twins or virtual reality systems are not just mirroring the physical entities or physical systems. Nowadays, with all the AI, sensors, IoT, everything coming into picture, we can really have real world scenarios replicate into these virtual systems. And that can support a lot of unsafety or some kind of environments where you can really go in and experience emergency situations or anything which is not really possible in real time in real environments. So that also helps a lot of end users to get upskilled and to understand what is with the system, what is with the autonomous systems which is coming up, and how we can encounter the issues and how we can rely on these technologies to solve those issues. So you are prepared well way before you are deployed onto the field.
Well, thank you so much. Derek, what's your opinion on leveraging this for upskilling workforce?
So we, at my team in particular, we don't focus a lot on providing like any XR-based training. So I'm going to talk about it from a different aspect of leveraging kind of what the company's already doing to train their for the particular jobs that they do. So and also how we kind of support the different use cases to help them do their job correctly, which they learn kind of like as they're doing it. So for example, there's like legacy training. They have tools in their PLM tools like TeamCenter and others that they have, and they've already spent a whole lot of time and money developing like step-by-step instructions how to do that. So what we did is we came in, not try to recreate the wheel, but just translate that to an AR experience. So we did a lot of work, and again, that saved a lot of money because we didn't have to create something from scratch, but then we can just take what they had already and just bring it to AR. Another aspect too is like many of the mechanics and technicians on the job, some of their jobs are repetitive and they don't necessarily need a lot of training because they do the same thing every day, but they do have to be wary of like line variations. There could be like for this one, there's a small change in how you put up, install these brackets because of this particular line, et cetera. And so, and by supporting that we have, and the others are like, you can't do that. Others is like, we have where you're installing like wire bundles, like it's this rat's nest of wire bundles. You could be doing this every day for 100 years. You're never going to memorize it because it's so complicated. And so we support multiple platforms like the HoloLens, where you need to be immersed and be watching how did this, just showing you where it goes, like, is enough, right? But it's hard just because it's a complicated mess. So, and the other one is like sometimes we have a tablet solution because, like I said, they repetitively do the job every day. They just need to check the line number or just make sure a quick check. So they just do it really quickly with AR and bring it up and confirm what they've done. So they're not necessarily, there's a lot of need for particular specific jobs, but just supporting them so they can do and make sure they're doing what they're doing is correct. So.
Well, thanks, Derek. And then I'm going to go out of order here for one time, but as we turn to our next topic on human-machine teaming, which we've already touched on, Sandhya, I am going to call on you first because you do research and focus here. And your work in the human-centered XR is yielding a lot of information probably a lot of us aren't aware of yet, but you're also then trying to immediately implement it across your workforce. And what do you think how does that look different across your geographic locations and where work roles and even technical fluency may vary? And I'm sure as all of our panel runs into, with a lot of the workers on your operational floors in the manufacturing area, they're getting so much technology thrown at them already. And what are you doing from a human-centric point of view to make these easier to adapt, more intuitive? What's your approach to some of that?
That's a great question, and it's actually a key focus area for us also. So effective human-machine teaming, to put it all right, is about empowering people to make faster decisions and more informed decisions in complex and uncertain situations or conditions. And having this kind of VR space where global teams can now pull into way before the product or ConOps or the system solutions is deployed will empower the people to understand better. XR is a big enabler here. Having those augmented reality overlays, for instance, for having that human perspective much more enhanced with features such as augmented tags, be it like in air traffic controlling, having augmented reality tags overlaying information can help them enhance their capabilities and skills in collaborating with humans and machines. When we talk about cobots also, collaboration between robots and humans, that comes under human-machine teaming again. So the robots can do much more higher capabilities than human. But how can we enhance human to also collaborate with these robots and get the system all up and right? XR is also enabling in terms of capturing human performance data for these human autonomy systems, so that we can build much more adaptive and intelligent human autonomy systems. For instance, XR embedded and integrated with AI features, because XR now can have is enabled to have body tracking, it's having gaze, it's having attention, but all these features are again cognitive human factors which can enhance much more collaboration between humans and machines. And I think this is very important enabler. XR is not just a communication tool. Going further, it can become an enabler for a lot of activities in terms of human autonomous systems or in terms of human-machine teaming. To enhance human capability is very important. On that note, like when it comes back to product design and development, the mindset we are changing and evolving is from a minimum viable product to minimum viable XR product, where the global teams can come into this uncertain and complex environments to solve the environments and to solve some system related issues and everything. So yeah,
it's fascinating. And I hope you'll share some of your research with the rest of us as soon as you're able to. And Alex, I know your team does an enormous amount of work on the human-machine teaming and adapting to new technologies. And in your environments, there can't be mistakes.
Right. Mistakes can be very expensive and incredibly dangerous. One of the most important, most most important or most transformative technologies is volumetric captures of the manufacturing environment. And if you have an array of volumetric cameras, you can have both a temporal and volumetric analysis performed. You could analyze the ergonomic postures of people in the work cells. You can get like a spaghetti map of their body posture, and that can be analyzed to design the work cell more effectively or in a more conducive manner to for us to reach rates. When we say rate at Blue, that means the rate of manufacturing. So we want to achieve that rate more effectively, and using that kind of an analysis of the shop floor is super effective. A hidden win, I suppose, of that kind of volumetric captured data is leveraging it with AI. So if we did have one of those big mistakes that you're talking about, or maybe even a little one, we could leverage AI to analyze the anomaly or the NC of non-conforming part, essentially a bug in the manufacturing process and byproduct, and then look at the volumetric capture and see everybody's role that they played from the first, from the inception of that, whether it's like an additive manufacturing, a part that's a byproduct of additive manufacturing, all the way to it being a flight article, and then figuring out where in that flow something went wrong. Humans are compartmentalize each step of the way, and even if a problem happens in one of those compartments per se, it's hard for us to figure out how these things go wrong. If you have an AI analyze the entire chain and use the data set for training material, we can start achieving root cause analysis through AI against volumetric captured data, and that's something I'm super excited about.
Thanks, Alex.
Hey, welcome.
How about you, Derek?
So I'll give you a little different aspect that we've experienced on the human-machine interface. So what you want to do for our technicians, I guess the principle that kind of like is we see that is problematic is do not frustrate the technician. So your program, your AR, you could have the coolest AR, fancy. You could have data from Star Trek appear, boom boom, talking to you. It doesn't matter if it frustrates the technician. So it's got to work. It's got to do what it's supposed to do. Like if you're overlaying and showing that, it's got to be clear and understandable. You can't have some user interface that is so complicated that you need training manuals to teach them the AR tool. It needs to be reliable. It works every time, as over and over again, and it works quickly because they're using it as a tool to do their job. They don't care that we made this little cool AR program. They're like, I need to get my job done and done correctly and efficiently. And so that we try to focus on that machine interfaces, reflecting those principles. And then on the other side is like when you get the adoption and the stuff by the user that they really like it, is when you see like how powerful it makes their job to do. And so like, for example, like if we have a fuselage coming in and it has thousands of brackets from a supplier that potentially one of them is missing or installed wrong and would cause a whole bunch of rework once you put all the padding, the blankets, and the wires up, and then you find out, oh, that bracket's missing, you got to redo all that work. It's expensive. So then you can see like, well, if they put on an AR headset or whatever, and then they can just see those thousands of brackets really quickly, the inspection goes easier. And then you add AI on there to help you do that inspection, then they're like astounded. So you have that positive aspect where you show the power of AR, and then don't do the negative. Don't make it painful for them. Do not frustrate the technician.
I'll add a little bit on that. Like the trust with the technicians or on the field of manufacturing comes when we have relevance and have simplicity and clarity of the entire application we are building. So giving the just amount of right data at the right time in a most usable format is very important, and it's a big lesson we've learned also in terms of human-machine teaming, in creating the interfaces, in creating augmented reality or mixed reality or anything, but overcomplicating and making it intuitive and non-intrusive is very important.
Those are great points. Hey, Derek, when you give the guys in the shop floor an AR headset, they say they feel like Iron Man.
We're afraid that we have to make sure that they can't get access to the games that are built in, so they start not doing their job.
And regarding your point, regarding obtaining their trust, sometimes it can be a little tricky when they know that they're being recorded on the device, and you have to kind of talk around that one.
Yeah. I mean, in the US, the rules are different. When it comes to Europe, then comes the GDPR, which is altogether different.
Yes.
And human data privacy, cybersecurity is all much more complex. And when we have to deploy this kind of solutions, that's the main consent, which is very important from the frontline user also. So, yeah.
I'm so glad I don't have to deal with that.
The other item that naturally feeds into is, then the challenges with scaling. And the more you involve the different workforce elements into your individual design, when you're designing up front and you're testing and you're starting to field it, that helps you scale better and increases organic adoption of the technologies. But I know that's not all of it. There's always hardware accessibility, different geographic locations, access to backbone technology. You already mentioned cybersecurity. That can be a real challenge when you're trying to scale these across locations and across different types of operational manufacturing lines. So Alex, how does your team tackle some of that?
Well, my little quip to her about not having to deal with GDPR regulations is because Blue Origin is we only manufacture stuff domestically. We're a defense contractor technically, because we make things that can deliver an object to the other side of the world in 25 minutes. So that is quite a capability. That is strict export control. So we only have manufacturing complexes in the US, so we don't have to deal with foreign cultures in that respect. But we do have teams with their own, I suppose, individual personalities. And when I build AR tools, I like to work with the shop floor leads in deploying something that makes the most sense. I create a program where I want to achieve certain end goals for us to reach that rate that I was talking about. But then I'll work with the respective shop leads to implement and make tweaks for what works best in those specific areas, whether it's Huntsville, Alabama, or the Cape, or in the West Texas desert, or here in LA.
And I know our earlier discussion, one of the challenges is you'll standardize an enterprise-wide rollout and the hardware changes.
Right.
Yeah.
That is a game of whack-a-mole.
Yeah, it
There's a huge problem waiting to be solved there, because AR solutions are downstream from changes, from things that are being checked in, and there is no companies talk about like recipe files and things like that, where if you have a model change, that it will send a flag. I want to see models being updated in real time against what's in the CAD PLM. And if companies like PTC are making, like Windchill, for instance, which is a popular PLM solution, it's a product lifecycle management tool. It's sort of like a CMS for heavy manufacturing. If companies like that are supporting the development of those and also supporting end user experiences in AR, there should be a unification in those software platforms that handle the problem that I'm describing. And that game of whack-a-mole is really tricky.
Yeah, so you've got your product line changes, and then you've got the XR hardware changes also,
Right.
where the headset goes away, and you're scaling it across 300 locations. And our team does deal with global locations, so we understand the different cybersecurity. So what's your approach to some of that, Sandhya?
I see it into three main categories. One, the people, the process, and the policies. When it comes to people, co-creating the workflows or co-creating the entire design and development cycle with the end users can support a lot. But integrating that to enterprise-wide applications is a big challenge because the workflows might be different. The digital skill might be different, and there is also a lot of aspect of change readiness, because one one application when deployed to a single entity
I'm
can
gonna
be.
get a water. I'm
Yeah,
sorry.
yeah.
I got a bug in my throat. Excuse me.
Yeah, but I'll continue. So, yeah, where was I? Yeah, a single application deployed on one floor cannot perform on the same aspects on another floor or another infrastructures. So, no, not at all.
Here, sorry.
Not at all. So, yeah, it might not work, and it comes up with the three P's: people, policies, and processes. Integrating XR into the PLM, as you've said, will be non-intrusive and making it much more natural. So it's not as a shiny tech or an experimental add-on, but it has to be embedded seamlessly into especially mission and military applications. And when it comes to policies, talking about the same cybersecurity policies or data privacy issues or anything, and collaborative design upfront to the enterprise or to the organization could also support in minimizing these risks of change management also. Yeah.
Oh, super, thank you. How about you, Derek?
I would talk about like what you were mentioning about the different platforms. You have to support different platforms. You can't be married to one platform. And that brings a whole bunch of challenges because, again, not just the hardware is changing, but even the underlying SDK using, whether using for your proprietary solution, Unity or Unreal, whatever, you have to keep up with those versions. And then you also are trying to leverage frameworks that work across multiple platforms. And then you find out, okay, this doesn't really work great on the HoloLens, but it works good on the iPad or whatever. Or we've had an issue where one of our QR scanners, when we went to a cross-platform one, it no longer had the resolution that our other one had, which was platform specific. So you just get a lot of headaches that you constantly have to deal with. So there's this great benefit of supporting all these platforms, which you have to do, but at the same time has a lot of challenges, just a lot of headaches and stuff that you have to deal with, just the reality of how things are implemented.
Yeah, and then of course you on the scaling side. I'm just curious, an ad hoc question. So with some of the tools you're using XR on the manufacturing floors, are you really thinking through hot swap batteries for stuff on your operational lines and making sure you've got those set up charging stations and all that
100%.
day-to-day stuff?
As well as making sure the devices are put back to charge at the end of their session. It drives me nuts. I see a headset sitting there, I'm like, oh my God, it's not charging. Yeah. You know, there's another important aspect that's sort of apropos for what we're talking about regarding, you know, things not being checked in and everything that it takes for a successful like AR solution to be deployed. One of the most important aspects is the physical to virtual alignment that's invoked from image markers.
Mm-hmm.
So I'm big on image markers, and because I've been building AR solutions since 2015, and we still have model drift. We've gotten much better with our sensor capability and the whole workflow to eliminate that. But for instance, there's a Fin on New Glenn, that's our heavy lift vehicle. And I have an AR solution in place right now. And it's only like maybe 15 feet by 8 feet high. There's 4 of them on New Glenn stage 1, if you look at the bottom of that booster engine. Anyway, just for that object that's about 15 feet long by 8 feet high, I have 4 alignment markers, but that's on the build stand, what we call the torque fin jig. And that doesn't move. And you don't always have that in the manufacturing and the work cell. You don't always have the capability to put image markers on things that will definitely not move. So I have a limited amount of time, and I'm in an environment that's just teeming with AR solution, XR solution opportunities. But I have my own acceptance criteria, and one of them is having those hard points that do not move for where I'm going to build my solutions. So I think that's something that a lot of people don't talk about. I thought I'd bring it up for you guys.
No, I think that's an important point because it directly impacts your safety, your precision, and the quality control.
Totally.
To have those things that aren't moving at all. That was the next topic area, was really going into quality control, and you kind of dived into that. I think that's important too, because sometimes I see this in a lot of applications, not just in manufacturing, where everyone thinks, oh, that drift is not a big deal. No, that's a big deal.
Yeah, centimeters.
That's a big deal.
That's where one hole could.
Yeah,
make less than-
in surgical theaters is a big deal. In precision and aerospace and aircraft manufacturing, it's a huge deal.
Yeah.
And I think like that, no, that little mistake and those intolerances are not acceptable. And I think that's why manufacturing can really drive the industry forward, because you have those higher standards that must be met.
That is a great point. I think the killer app for spatial computing is heavy manufacturing. We are bringing the ball down the field because we have the funding. Earlier on we talked about a mistake could be very expensive. So the impetus for the funding for our projects to buy headsets that might be $6,000 to $7,000, and the way that on the shop floor we're figuring out the best UI and the best end user experiences in general, we're doing the heavy lifting that's going to be exhibited in the end user commercial solutions. So, let's hear it for us, doing the heavy lifting.
I would like to elaborate on I call it like
that guy. Thank you.
I call it like the holy grail of the manufacturing is this, I don't know what the term is, but automatic spatial registration, where without all the massive setup of markers or whatever, you could just come into the work area, it aligns accurately.
Yeah.
When you get there, that's
The
when
best.
things are their goal. Yes, that would be amazing. That would be a leap forward. Yeah.
Yeah, and I want to leave a little bit of time for questions, but we kind of just started diving into it. So, Alex, if you could have anything right now for the next frontier, what do you see? What do you see coming next?
I did talk about volumetric captures. I think that, and I was mentioning how I lead two initiatives, augmented reality for manufacturing and reality capture. And there's a through line there in that Venn diagram where I could take that digital twin and then I could use that data to design my AR scene. Well, I cannot wait till we have volumetric capture arrays that we can analyze the end user ergonomics, the guys on the shop floor. We could start messing around with the shop floor layout by bringing models in from the CAD PLM right into the data from the volumetric capture. And I could use the volumetric capture to design my AR scenes, as well as also embed IoT data into that as well. We didn't even talk about IoT. We could do a whole panel discussion on that specifically, and that's a lot of the digital twin area. So yeah, to answer your question, a really robust volumetric capture array that has the analytic capabilities that I'm describing. That's, if I could have anything in the context of this conversation, that's what it would be.
Cool. What about you, Sandhya?
So for me, it should be interoperability, like spatial computing systems with data streams, with XR. How can they work all together? The tools, the themes, the infrastructure it demands to make all these volumetric displays or spatial recognitions, or having humans and robots collaborate together, because XR plays a huge role in these aspects also. And how can we have that perfect spatial alignment to make these things much more enhanced and optimized? That could be a really good leap further, to see those tools, to have those working and everything.
I urge everybody to take a look at a company called Data Time Space. They just came out of stealth mode. They were spun out of MIT Reality Lab, and Valentine Huhn, the founder of that company, he has the right idea regarding volumetric capture and some of the things that I talked about, that we're talking about.
Yeah, and that's a good point. If I go back to my early days in defense, just walking into an immersive sim cave, you would spend 30 minutes getting wired up because you had to have RF sensors all over the place to go in and, and we've come a long way with some of the evolution in the 6 degrees of freedom and volumetric capture and some of those tool sets. And I'm really hoping there's a day when, again, those all work together and there's a common API to hook them all together fast. So you're not node locked, you're not hardware locked, you're not headset locked. These things can just be fluidly migrated across, because the hardware is going to continue to change.
Yep.
So I'm looking forward to seeing how those all get merged together. So what's your opinion on it, Derek?
I think the most growth area probably, and which makes a lot of sense, is combining AI and AR together. Like right now when we're doing inspections or, it's very stovepiped. We're looking at brackets. So we have a model for brackets. We have the AR CAD for brackets. The ID does its detections. There may be some that it doesn't find or that, and they use the AR to go follow up to make sure they're correct and so forth. And then you go to wire install, then you go to maybe fasteners or clamps, whatever. It's all kind of that. It's not really integrated. And then I think where you have the manufacturing and inspection process merged together and helped with AI so that you can be more conversational with it. Can you inspect it? Do you detect any errors with these fasteners? And it automatically finds one. Does the quality report capture and all that stuff for you automatically? Because this is such a tedious bunch of work for a technician to do. And if AI can do all that tedious work and do it more accurately, faster, and better, and easier for the user to use, so they don't have to use some weird interface and all this stovepiping solutions we have, where it's just much more flow. I think that's when you're gonna have the most progress. I think there's a lot of work there to be done, and it's real work. It's achievable.
I'm with you, man.
Yeah, I agree. And I think there's a lot of concern about the appropriate use of AI. And I think that the more that groups like ours push this forward and it's a positive tool, I think that'll lead to more organic acceptance, because occasionally you have staff that are very concerned about that, but it's such a force multiplier. Yeah. And it's going to let all of us achieve more higher levels of our own human performance, because it can accelerate everything for us if it's leveraged properly. Yeah. And I think building out those blueprints and some of what the projects all of you are working on are laying the groundwork for how we standardize this and scale it. And that's what I'm excited about, to see when we're here all together in 5 years.
Let's do it.
What are we going to talk about, in 5 years? And I know a lot of you in the audience may have some questions. So please come up to the microphone and ask our panelists, any of our great panelists, some of your questions. It's fun because it will be totally different in 5 years, right?
We should really do it.
We're going to be talking about something wildly different in 5 years.
Maybe out of work.
Question?
AI taking
Yes.
over.
Thank you for the insightful session. My name is Kelvin. I'm a collegiate entrepreneur. And I wanted to ask you, how relevant would you say hand tracking is in the areas that you're working right now? And in the future, how relevant or what potential do you think hand tracking has in XR applications?
Yeah, well, usually like the dichotomy of hand tracking versus controllers, I bucket that in virtual reality, and AR is all hand tracking as far as the user interface and the interactive menus that I'm accessing. So all about hand tracking. Go for it.
No, hand tracking is quite important also in the applications we do. For instance, when we have like a fully immersive aircraft environment, intuitive interactions to get that human feedback for the assessment of the design is very important. And giving those intuitive interactions, not with controllers, but with hands, where they can like turn a knob, take out a coffee maker very intuitively as they do in real life, does have a much more impact on the human-centered approach what we are doing. So I guess, yeah, it has a pretty intense operations in what we want to achieve.
Yeah, it's focused mainly on the headset aspect of AR, where that makes relevance. And again, I'll come back to the principle I mentioned before. Do not frustrate the technician. So there's limitations, the compute power to do the hand tracking on the device itself, and how accurate it is. So we've had issues where there's like background processing and we're trying to hit a button, and just because of the interruption, it double clicks. That frustrates the user.
Yes.
There's hand tracking, if it can improve and it's within the compute of the headset, then it's really good. And as long as, again, don't frustrate the technician.
In the same vein, Derek, holographic keyboards are just so nasty.
Yes.
Yeah, they are the worst.
Yes.
Yeah.
And I think hand tracking, it's important on a live manufacturing floor that they be very specific, simple gestures. You have operators that are very busy and they're in a hazardous environment with a lot of equipment moving. So any systems that are designed that are dependent on specific clear audio, which may be impossible on a manufacturing floor, or any kind of specific, very detailed gestures can be challenging. And any interfaces, particularly to interface with the system to accept a yes or no on quality or good or bad, it has to be very generic. So it's easy and intuitive for them. When you're in a full VR training environment and there are very detailed, specific gestures and motions that have to be done as part of the manufacturing workflow, and it's a training application, it's very important that those be highly accurate, because the training is intended to build cognitive repetition and cognitive understanding, but also build muscle memory. And it's important that those are very accurate. So I would advise you to be very thoughtful in designing those solutions to make sure you're matching form to function.
All right, that's all the time we had. Let's give a huge round of applause for our amazing panel. Thank you.